Welcome to the third video in Lesson 3, where we will review an idea you may have been introduced to in grade 6, that being two types of data, namely discrete data and continuous data. Revision of these data types is necessary before we continue our analysis of the measures of central tendency. What is discrete data? Discrete data is a set of data whereby there are values between those given that are not meaningful in the context of the problem. The data values cannot be divided into smaller, meaningful parts. Data can be counted, like counting sheep. Graphically, we do not connect the data values or the points when plotted. Some examples: number of multiple choice questions answered correctly. You can get one multiple choice correct, or two multiple choice correct, or three. You cannot get 1.5 multiple choice questions correct. The number of home runs in a baseball game. You can hit one, you can hit two, but you're going to have a hard time hitting 3.25 home runs. It's either a home run or it's not. The number of students in a class. We cannot have partial students. So, partial home runs doesn't make sense. A partial game number doesn't make sense. Partial sheep. In the context of counting sheep, counting holes, partial sheep does not make sense. What about continuous data? Well, this is data where there are an infinite number of values between data points, which all make sense in the context of the problem. The data values can be divided into smaller parts. The data tends to be measured. Graphically, we do connect the data values or the points when plotted, and it makes perfect sense. Some examples: height, temperature, time. We can have partial height, partial temperature, partial time, all possible. If we consider time, for instance, we can take years, break it down to days, break it down to hours, to minutes, to seconds, to milliseconds. These smaller parts make sense. Same thing with distance. If we start with a kilometer, we can break it down to a meter, to a centimeter, to a millimeter, and go even smaller. Temperature, great way to consider continuous data. If you look at a thermometer and you see the mercury rising, guess what? That's a continual, a gradual increase. This continuous increase leads to continuous data. It is not unusual, even for students in senior high school, to be challenged at times distinguishing between discrete and continuous data. Take some time to reflect on this material. You can do it. And now I'd like you to proceed to the next video in this lesson.